This video is about triangular numbers. They have the name because we put a dot there, and then in the next row we put two dots. That's a little triangle. So the idea is to count how many dots are there making the triangle. But this triangle is growing one row at a time, and every time we add a new dot to the last row. So for example, here we have 5, and the previous one we had 4, and now we have 5, and here we're going to put 6 dots. So there are a few triangles there, but the triangle keeps growing. Now let's take a look at the number of dots that we have. First, we have only 1, right? That's the first triangular number. Then we added 2 dots, so now we have, in that second triangle, we have a total of 1 plus 2, which is 3. That's the second triangular number. Then in the third row, we are adding 3 dots. So for that triangle, the total comes to 6, because we had 3 and then we are adding 3. Now we have 6. For the next triangle, we added a row with 4 dots, so now we have 1 plus 2 plus 3 plus 4, and then 6 plus 4 equals 10. This is how we build a sequence of triangular numbers. 1 plus 2 plus 3 plus 4 plus 5. We take the previous sum and then we just add the next number, and notice that the numbers that we are adding are consecutive integers starting from 1. So here we're going to have 15. So that's the sequence of triangular numbers. We start with the number 1, and then we add 2, so that gives us 3. And now we add 3, that gives us 6. We add 4, we get 10. We add 5, we get 15. We add 6, we get 21. Now 21 plus 7 is 28. Now we add 8, and 28 plus 8 equals 36. So we added 8, now we are going to add 9, and 36 plus 9 is 45, so that's the next triangular number, 45, because we added 9. Now we're going to add 10, so 45 plus 10 equals 55, and that's the way we continue. Now we add 11, and we get 66, and then we add 12, and we get 78. So those are the first 12 triangular numbers. So this is the sequence of triangular numbers. Now there is an interesting story related to this sequence, and it's about a boy who lived in Germany somewhere in the 1800s, and at that time, when he was going to school, he had a teacher, a math teacher, who used to put his students to solve this problem. So the teacher would write in the board this sum and ask his students to calculate that sum. So he would just write some numbers, and the first few, 1, 2, 3, and then they were supposed to keep adding plus 4 plus 5 all the way to 100. And that would keep the children busy, occupied for a while. And of course they were going to make a lot of mistakes along the way. Now the story is this this kid whose name was Carl Friedrich Gauss. He thought of this method. He said, okay, well, that sum is going to be some number, so let's call it S for sum. And he just put that with, without trying to calculate the first few terms or before starting adding anything, he just wrote the sum and said, well, this is going to be some number. But look at all these numbers. They are consecutive and they are increasing. They all go up by one by one. And they are sorted in an increasing order, like from least to greatest. What if we rewrite the sum backwards in a different order? We sort the numbers now in decreasing order from greatest to least. And we do this, so here we're going to finish at 100, 99 here, and 98. So he just reverse the sum, but these are the same numbers. They are just written in the opposite order. So the result of this is the same number because we are adding the same terms. Now his idea was, well, what if now we add these two sums vertically, right? Because basically they are the same sum, but now we have like two equations. So what happens if we add the two equations? Now we have the sum repeated twice. So whatever that number is, whatever value we get, if we add two of those, we are going to get double of that. So 2 times the value of the sum. And right now we still don't know how much is that sum. We're going to find out, but at this point we don't know. But let's see what happens on the right hand side of the equation. Here we have adding vertically 1 plus 100 is 101. Now how much is 2 plus 99? That's again 101, right? And how much is 3 plus 98? That is again 101. So this keeps happening because as we move along, the numbers in the first sum, they are increasing, they go up by 1, but at the same time the numbers in the second sum, they go down by 1. So one goes up, the other goes down, so that the sum remains the same. It's a constant number. All of these vertical additions of two numbers, they are, see, 99 plus 2, they are always going to be 101 all the way from beginning to end in this sum. And so now that we have this sum of 101 plus 101, it's a repeated addition of the same number. That is multiplication, right? Because we are counting, we are adding the same number. So if we convert this sum into a multiplication, we only need to find out how many copies of the same number we are adding, and we can just count them because they are already, we can counting by one, 1, 2, 3, 4, 5, 6, etc. So we go all the way to 100. So this is the number 101 repeated 100 times. So now we have that for the double the value of the original sum. If we want to find the value of the sum just once, not twice, we can do that multiplication and divide by 2. Or better, since one of those two factors, the number 100, is an even number, we can divide that by 2, and then we get this result is 101 times 50. So instead of multiplying 101 times 100 and then divide by 2, we can divide the 100 by 2, and that's 50, and then 101 times 50, the result is 5050. Now, for the general sum, when we are extending this method of calculation to an arbitrary number of numbers that we are adding, let's call it n, equals a number of terms in this particular sum for a triangular number. We are going to have this same method, same process. So the sum, we can express it as 1 plus 2 plus 3 plus dot 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 all the way up to n. So we write n minus 1 before the n, just in the same way that when the n was 100, the n minus 1 was 99. And so we now do the same system. We're going to rewrite the sum, same sum, but with the terms now being added in decreasing order. So we are reproducing the technique that we used in the example with 100, but now we're doing it with a general number n. That's the number of terms we are adding, and also the value of the maximum term in the sum. So n minus 1, n minus 2, and so on until we get all the way down to here plus 2 plus 1. So reversing the sum in the same way we did before, and now we're adding vertically. So we are getting on the left hand side of the equation, we are getting the quantity 2s, so 2 times s, the double of the sum. And here we're going to get a repeated sum of the same number, so 1 plus n, so n plus 1, adding vertically, and then all these terms, see, at the top we have the numbers going up by 1, at the bottom row the numbers go down by 1, so n minus 1 plus 2 is again n plus 1. So here we have our constant term, n plus 1, all the way to the end of the sum. This other sum with a constant term. So we are repeating, adding copies of the same number, but how many copies? Again, here we can count them, 1, 2, 3, 4, 5, 6, etc., all the way to n. So that's how many, right? The number of terms. So the double of our original sum, the quantity 2s, equals n times, so n is the number of copies of the number n plus 1. This is our constant term that we got there in the combination of those two sums. And now we divide by 2 on both sides, and we get our sum equals that product, a number n times the next number. For example, if n was 5, the next number would be 6, and then we do 5 times 6, that is 30. And then when we divide by 2, we get 15, which, as we saw in the previous examples at the beginning of this video, is one of the triangular numbers, and so on. If the n is, let's say 7, the next one is 8, so 7 times 8 is 56, and divided by 2 is 28, so that's another triangular number. Now the general formula with sigma notation for this is adding numbers, consecutive integers, starting with the number 1 and finishing with the number n, the last term. If we just add these numbers, notice that these are all consecutive numbers, not evens or odds or powers of anything. It's just that number k from 1 to n. The result of that sum is our triangular number that we have here in the result of that, n times n plus 1, and then this multiplication divided by 2. But you can always, since n and n plus 1 are right next to each other, one of them is going to be odd and the other one is going to be even, so you can always divide the even by 2 first and then multiply times the other, and that's the formula for the summation. And of course this formula needs to be proven by mathematical induction, but that will be again a topic for another video.